Hi folks, this is Applied Calc 2 Checkpoint Quiz 7. We're given some fictional data from a fictional city. So this is apparently taken from Gotham City. The proportion of population is given to us as x, and the proportion of income then is given as L of x. So L of x represents our Lorentz curve. Part A asks us to use this data and the trapezoidal rule to approximate the integral from 0 to 1 L of x dx. And then we'll use our answer to Part A to approximate the Gini index for Gotham City. So let's review here the trapezoidal rule. So if I want to approximate the integral from a to b f of x dx, I'm going to take that interval a to b and I'm going to chop it up into n equal pieces. So we're going to get ourselves a partition. The left most endpoint is A, the right most endpoint is B. And since this is what's called a regular partition, we're chopping it up into equal pieces. So the delta x is the length of each piece, it's all the same. The length of the entire interval divided by the number of pieces n. So if we go and chop up the interval, sample the function at these points, if instead of drawing rectangles we draw trapezoids, then we can approximate the integral using the formula b minus a over 2n, so delta x over 2, times f of a plus 2f of x1 plus 2f of x2, etc., plus 2f of xn minus 1 plus f of b. So we take the function value at the endpoints, and then we double all the function values on the inside, add all that up and multiply it by b minus a over 2n, and that's the area under that curve as approximated by trapezoids. So in our example, we're looking at the integral from 0 to 1, L of x dx. So the interval we're chopping up is 0 to 1. That means we should start off with 0 as a left endpoint. But you'll notice in my data I don't have a 0 for x. Well, think about what this represents. If I have 0% proportion of the population, what should the proportion of the income be? It should be 0. So that's going to be okay. And the other partition points, looks like they're going increments of 0.2. So we've chopped this interval up into how many pieces? 1, 2, 3, 4, 5 pieces. So the trapezoidal rule said the integral from 0 to 1, L of x dx, is roughly equal to b minus a over 2n. 1 minus 0 over 2 times 5 times the function at the leftmost endpoint, L of 0, plus 2 times the function value at the intermeeting points, plus the function value at the rightmost endpoint. So this is equal to 1/10 times L of 0. L of 0 is 0. Plus 2 times L at 0.2. L at 0.2 is 0.05. 0.05 times 2 is 0.1. Plus 2 times L of 0.4. 0.2. Plus 2 times L of 0.6. It's 0.3. Plus 2 times L of 0.8. That's 0.4. Plus L of 1, which is 1. So now I add all this up. 0 plus 0.1 is 0.1. 0.1 plus 0.2 is 0.3. 0.3 plus 0.3 is 0.6. 0.6 plus 0.4 is 1. 1 plus 1 is 2. 2 times 1/10 is 0.2. So this is roughly 0.2. So how do we compute the Gini index? Well, the Gini index is defined to be 2 times the integral from 0 to 1 x minus L of x dx. So the distribution x represents a completely egalitarian economy. The wealth is evenly distributed. And the L of x, in reality, is not evenly distributed. So we're looking at this difference, integrating from 0 to 1, and then in order to get a number between 0 and 1, we multiply our answer by 2. So if you recall, that's how the Gini index came about. Now, we have an approximation for the integral 0 to 1 L of x dx. So what we can do is use properties of the integral to break this integral up into 2 parts. The integral from 0 to 1 of x dx, I can use the fundamental theorem of calculus to evaluate that, or heck, I can even go back to geometry and figure that out. No matter how you slice it, this is 1/2. The integral from 0 to 1 L of x dx we only have an approximation to. So this is really an approximation of that. And so we get 1 minus 0.4, which is 0.6. So the economy of Gotham City is skewed more towards inequality because the Gini index is more towards 1 than it is towards 0. And so that'll do it for number 1.